Hello everyone and welcome to iLAN Technologies' presentation on securing the LAN with Draitec Vigor switches. Network security is now a major consideration when designing data networks. In this first part of this two-part series, we'll look at how to improve security on the LAN by utilizing the security features available in Draitec Layer 2 and Layer 2 Plus Vigor switches. My name's Darren and I'm the Queensland sales rep at Draitec Australia and New Zealand. We'll start out today by looking at why we need to look at security within the LAN and consider some of the Vigor switch features that can be used. We'll look at client authentication where we use MAC address and port binding with 802.1x MAC authentication. This method is usually recommended for DHCP clients. The other method for client authentication is to use MAC address, port, IP address, and VLAN binding with IP source guard enabled. This method is recommended for static IP clients. Another feature we'll look at is client isolation. Here we can isolate ports entirely with protected ports. This is recommended for landlords and hospitality. We can also isolate attacks with DHCP snooping and dynamic ARP inspection. This is recommended for office networks. Stay tuned at the end because we'll be online for 5 minutes afterwards to answer any questions. So let's start out by looking at why we need a secure local area network. The local area network is the primary focus of cyber attacks for many companies and businesses. While many attacks come from the internet, it's still very easy to introduce malware and viruses from portable devices such as laptops and USB flash drives that are brought into the workplace by users. Routers and firewalls are good at stopping attacks from the internet, but not so good at blocking attacks that come from inside the LAN. So the solution here is to use a Draitec Vigor switch to protect devices connected to the LAN. The Layer 2 features in Vigor switches can protect from attacks by utilizing features such as client authentication, client isolation, access control, and more. I'll go into more detail later as well as go through some of the different scenarios which will hopefully explain the advantages. Here we have an illustration of those factors. In general, we tend to have an advanced firewall protecting our network from internet attacks. However, the local area network is still vulnerable since we can't prevent LAN-originated attacks. In most cases, Layer 2 attacks happen on the LAN before traffic reaches the firewall, so the firewall will not be much use here in dealing with those. It should be noted that threats coming from the LAN can be fast spreading, potentially bringing down the network, but can be prevented by a Vigor switch. So let's look at how. The first Vigor switch feature we'll look at to improve LAN security is client authentication. Just to recap the intro, with client authentication there's two methods that can be used. First, we can use MAC address and port binding with 802.1x MAC authentication. The other method is to use the MAC address, port, IP address, and VLAN binding with IP source guard enabled. 802.1x MAC authentication is usually used for DHCP clients since we don't know the IP address of the devices before they connect to the LAN. The more secure method is to use IP source guard, where we use MAC, port, IP, and VLAN binding. So looking at 802.1x MAC authentication first. With 802.1x MAC authentication, we can control access to every port on the Vigor switch. We can use the allowed list to allow device access or use the block list to deny access to a switch port. There are two authentication methods that can be concurrently used on a single port, which are 802.1x or MAC-based authentication. The table here provides a comparison between these two methods. 802.1x provides higher security since it uses EAP, which is an abbreviation for Extensible Authentication Protocol. It's a standard mechanism to authenticate on the network. It requires a radius server to store authentication details, and the 802.1x supplicant is required. The supplicant is the entity at one end of the point-to-point LAN segment that seeks to be authenticated and can be either hardware or software. I'll go into more detail how this works shortly. This method is recommended for small to medium enterprises requiring high information security. On the other hand, MAC-based authentication provides a more basic level of security, a radius server is not required, and you can create the account details locally on the switch. This method is recommended for small to medium business and SOHO applications. Here we have a diagram showing the 802.1x authentication process. So we have the supplicant on the left, the switch in the middle, and the radius server on the right. When a client connects to the switch, it will have no connection since it's not yet authenticated. The switch will send an EAP request to ask, is there anyone new on this network? The supplicant responds with a message that it is new and provides its details. The request is forwarded to the Radius server, which then replies with a Radius access challenge. The switch will forward this to the supplicant, which responds with its credentials. The Radius server checks the credentials and allows the switch to provide access for the LAN client. For MAC authentication, the process is much simplified. When a client connects to the switch, it will have no connection since it's not yet authenticated. The switch will check its local MAC account database or send the details to a Radius server if configured. Once authentication is successful, the switch will provide access for the LAN client. For each switch port, we can apply 2 authentication methods to run concurrently, and we can configure which one to go first. In this example, we specify that 802.1x comes first, and if we get EAP failure, then MAC authentication is tried. To set up 802.1x and MAC authentication, we need to first set up the global settings in the VigaSwitch. You'll find this in the VigaSwitch menu under Security, 802.1x MAC Authentication, Properties. Then select the Global Settings tab. In the Authentication Type section, we can specify which authentication types to use and the order in which they will be used. Since it is a global setting, it's a good practice to select both here, and you can select one for an individual port if required. This setting will apply to all ports on the VigaSwitch. Selecting Enable for Guest VLAN means that any clients that are not authenticated will be placed in the guest VLAN with the selected VLAN ID, which will have limited access to network resources. After setting up the global properties, the next step is to set up the port properties. This is in the same place under Security, 802.1x MAC Authentication, Properties. Then select the Port Authentication Settings tab. The authentication types will be a subset of those specified in the global settings. For host mode, we have 3 types we can select. These are multiple authentication, multiple hosts, and single host. Multiple authentication is used when this switch port is connected to another switch, and every host connected through this port should be authenticated. Multiple host is used when you have an access point connected to the switch port and it just needs one host to be authenticated to allow other hosts to connect without authentication. Single host is used when you have a single device, such as a PC, connected to the switch port. We also have the guest VLAN option here, which can be enabled if needed. The authentication type and servers can be entered in the required order. In this example, we have 802.1x to be first, followed by MAC-based authentication. For the server, we have Radius first, then local. The third step is to set up the port control settings. In the VigaSwitch menu, this is under Security, 802.1x MAC Authentication, Port Control Settings. The most important setting in this page is port control. There are 4 options here, which are Disabled, Force Authorized, Force Unauthorized, and Auto. By default, all ports have port control disabled. Force Authorized means that all connecting hosts are considered authorized and can connect without authentication. Force Unauthorized means that all connecting hosts are considered to be unauthorized and are blocked until authenticated. Best practice is to set up port control to be auto. This way, connections will be passed or blocked depending on the rules set up in the accounting database. Let's go through a demonstration of MAC authentication using the network topology shown here. Okay, so the router we're using is the Viga 2927 LAC. This router has 2 VLANs configured. LAN 1 is the primary LAN and LAN 2 is the guest VLAN. And we're using the VigaSwitch P2540X as the main switch here. Port 13 of this switch will be configured for multiple authentication, meaning that all devices connecting to this port will need to be authenticated. Port 13 will also have guest VLAN 20 enabled as well, so any devices not authenticated will be placed in the guest network and obtain an IP address in the 192.168.20.x subnet. Authenticated devices will be placed in LAN 1 and get an IP address in the 192.168.27 subnet. Port 14 of this switch will be configured for multiple hosts, meaning that once one host is authenticated, then other attached hosts do not need to be authenticated. As you can see here, the router has the 2 LANs configured. LAN 2 will be the guest VLAN. Now we will start to configure the switch. We go to the Security menu and 802.1x MAC Authentication. We start with the Properties Global Settings. For authentication type, we enter both 802.1x and MAC-based authentication. Also enable guest VLAN and assign a VLAN ID of 20, which corresponds to the VID set up in the router for the guest subnet. Now go to port authentication settings. Apply the setting to port 13. Enable MAC-based authentication, and for host mode use multiple authentication. And select local database. Guest VLAN is enabled, so any devices not authenticated will be directed to the guest network. Now set up port 14. Select MAC-based authentication and use multiple hosts for host mode so that once one host is authenticated, then other subsequent attached hosts do not need to be authenticated. Enable MAC-based authentication and select local database. So we can see ports 13 and 14 configured here. The next step is to go to port control. For ports 13 and 14, we enable auto mode. Now we create a local account. Here we entered the MAC address of the VigaSwitch 2280X. We now connect this device to port 13 of our main switch and check the authenticated host list in the switch to see if this device is authenticated. So we can now see that the attached device is now authorized. Now we can check on the router cache table to see which LAN subnet the device has access to. We can see that it has an IP address of 192.168.27.13, which is in LAN 1. We'll connect a second device, which is the Viga 2860, to the 2280X switch. This second device will not be authenticated and should go to the guest network. Okay, now connecting the 2860 to the switch. If we now go back to our main switch, we can now see that the second device comes up as guest status and is in VLAN 20. Checking the ARP cache on our main router, we can see that the second device has an IP address of 192.168.20.11, which is in the guest network. Connecting to this IP address gives us the Viga 2860 router. We'll now repeat this test and connect the 2280X to port 14 on the main switch. Since port 14 is configured for multiple hosts, we expect to see the first host to be authenticated, and then any other devices connected after this will not need to be authenticated. Now the 2280X is connected to port 14 on the main switch. Checking the authenticated hosts, we can see the status is authorized. Now connecting the 2860 to the 2280X. Okay, let's now check the ARP cache on the main router to see what IP address has been allocated to the second hosts. We can see that it has been allocated IP address 192.168.27.18, which is on LAN 1. So since the first device was authenticated, the second host did not require authentication before connecting to the network. Now we'll look at IP SourceGuard, which is more secure and is recommended for static IP clients. This method uses the MAC address, port IP address, and VLAN binding along with IP SourceGuard enabled. IP SourceGuard will block all users not on the list. It also blocks IP and MAC spoofing, so the network administrator does not need to identify the source of the attack. The VigaSwitch can restrict IP traffic on the ports by checking the combination of IP address, MAC address, and VLAN. It can use auto-learning based on the DHCP snooping binding database, or it can use a manually configured IMPV binding, IMPV being IP, MAC, port, and VLAN. To configure IP SourceGuard, we enable it on a single port, then go to the IMPV binding menu to set up the bindings. Let's go through a demonstration of this setting. So here we'll bind the IP address, MAC address, VLAN, and port of the AP903 access point in this example to port 15 of the VigaSwitch. We'll enable IP SourceGuard on both ports 15 and 16 of the switch. We should see that the AP903 can connect to port 15, but will be blocked on port 16. So let's go to the VigaSwitch and change the settings first. To configure IP Source Guard, we go to the Security menu and IP Source Guard submenu. We use ports 15 and 16, enable it and select Verify Source to be IP with MAC. Now go to IMPV binding. Notice that there are two types of binding in this table. One is static and the other is dynamic. The dynamic entry is learned from DHCP snooping, which we'll talk about later. We manually configure the static entry. We've created an entry for port 15 where we have entered VLAN 1 and the MAC address of the access point, and it should only use the IP address 192.168.27.14. The binding type is IP MAC port VLAN. Now we'll connect the access point to switch port 15 and we expect it to be allowed to connect to the network. We can check if it is connected by going to the router and check the ARP cache table. We can see here that it has connected successfully. Now verify that we can connect to the IP address. So, looks good. Now I'll move the access point to port 16. Since its details are configured for port 15 only, we expect the access point will be blocked. Okay, let's check the router ARP cache table again. We see now that the access point is not connected to any VLAN on any port, and we can't ping it. We'll now look at the client isolation feature. With client isolation, we can isolate ports entirely with protected ports, and we can also isolate attacks with DHCP snooping and dynamic ARP inspection. Let's first look at protected ports. This is the easiest way to protect the LAN environment. It isolates LANs regardless of VLAN settings. It blocks communication between ports so no viruses can propagate between LANs, and attacks are blocked as well. So what's the difference between VLAN and protected ports, since VLANs can also isolate hosts as well? The answer is that VLANs are used to isolate broadcasts. Each VLAN is a broadcast domain. Protected ports add another layer where switch ports within the same VLAN are isolated from each other. When enabling this function, the switch will have both protected and unprotected ports. Here, protected ports can only forward traffic to unprotected ports, but unprotected ports can forward traffic to both protected and unprotected ports. To enable this function, you just need to select the ports to protect and enable. Now we'll go through a demonstration of this setting using the network topology shown in this diagram. In the VigaSwitch, we'll have both ports 17 and 18 set up as protected ports, so ports 17 and 18 will not be able to communicate with each other. They can only communicate with unprotected ports. To configure protected ports, in the VigaSwitch menu, go to Switch LAN, Port Setting, Protected Ports. Here we select ports 17 and 18 and select Enable. We can now see that ports 17 and 18 are enabled as protected. So now I'll connect an access point to port 17 and a router to port 18. Okay, let's now try the router ping tool to check if we can ping the access point. We expect to not be able to ping while protected port is enabled, but we should be able to ping when protected port is disabled. From the Viga 2860, we can see that we get ping timeout just as we expected. Let's now disable protected ports. Running ping test again, we can see that we now get ping response. So this shows how you can isolate switch ports using protected ports. Let's now look at DHCP snooping in more detail. DHCP snooping will prevent unauthorized DHCP servers from servicing DHCP requests on the LAN. It will also prevent man-in-the-middle attacks, which may redirect clients to a malicious gateway or DNS server. DHCP denial of service attacks are also blocked. To configure DHCP snooping, we need to set up the trusted ports for valid DHCP servers. This allows DHCP server messages, offer and ACK to flow through the trusted ports. These messages will be blocked through untrusted ports. In this example shown here, we've selected GE1 and GE2 as trusted ports, and all others will be untrusted. Enabling Verify Chatter will compare the client hardware address with the source MAC address in DHCP messages. Chatter, or maybe CHAtter if you prefer, is just an abbreviation for client hardware address. If they don't match, then the packet will be dropped. We can also set up the rate limit to prevent a denial of service attack caused by DHCP flooding. The final item we'll look at today is client isolation by using dynamic ARP inspection. This will prevent ARP spoofing to protect LAN clients from getting no connection or being eavesdropped from man-in-the-middle attacks. Dynamic ARP inspection will inspect ARP packets and only pass packets that match the IP and MAC binding in the DHCP snooping database. Okay, so this is the end of our presentation today. To summarise, we looked at why we need a secure LAN to protect our network and showed that Draitec Vigor switches have many security features to facilitate this. We covered client authentication using MAC port binding with 802.1x MAC authentication, as well as MAC port IP VLAN binding with IP SourceGuard. We also looked at client isolation using protected ports on the Vigor switch, as well as DHCP snooping and dynamic ARP inspection to isolate attacks on the network. Okay, that's it for me, but please stay tuned. Staff will be answering questions in the live chat on the right of your screen for the next 5 minutes. For more information about Draitec products, please check out our website at www.draitec.com.au or send us an email to sales@draitec.com.au or give us a call on 02 9838 8899. Don't forget to like and subscribe below, and if you'd like a notification of new Premiere videos we're about to launch or anytime we put up a new video, please give the bell a click too. Thanks and bye for now.